right, Ethan. I stayed late today, so I don't have to do this in the morning. All right. So we're gonna skip around just a little bit. You did section 4.1 yesterday. I assume you thought that was pretty easy. You flew through it. So today we're gonna do sections four. The first day of sections 4.2 and 4.5. The most people wait for the 4.5 stuff. I think it makes more sense to just get all the congruency theorems out of the way at the same time. So, why is my printer blinking at me? Okay, it's all right. So, first, if two triangles are congruent, we learned in the last section that the 6 parts of one triangle are congruent to the 6 corresponding parts of the other triangle. And sometimes, though, you don't know going in that the triangles are congruent, and you have to prove that they are. And there are going to be 5 ways to prove it. What's it doing? Here we go. These are the 5. And anytime it says an S, you're going to say the word side. Anytime it says A, you're going to say the word angle. And HL, this is hypotenuse, leg. All right. So the 5 ways are side, 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 angle, angle, side, angle, 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 side, and hypotenuse leg. But this last one only works on right triangles. So we're just going to go through them all and make sure you understand. So pretty much, if you have 2 triangles, here they sit. And maybe this is triangle ABC. I don't know why I put A so far away from the triangle. Oh my gosh, what am I doing? Okay, did it again. Change it to the pen, Gwen. Okay, so A, and then over here we've got D, E, and F. All right, and I tell you, this side length's the same as this length. You might even have numbers, but you don't have to. You know, it's just got to be, oh, these sides are congruent. These sides are congruent. And these sides are congruent. There is no way around those 2 triangles being congruent to one another. And you would say that triangle ABC is congruent. All right, and so angle A sits between the side with 1 tick mark and 3. 1 tick mark and 3, that's where angle D sits. So angles A and D correspond. Angle B sits between the sides with 1 tick mark and 2 tick marks. That's where E is. And then that leaves F at the end. But there's a reason. By the side congruency theorem. And you don't have to, this is a postulate. Congruency postulate. People don't write the word postulate. They just put side congruency. I mean, you can if you want to. So there's 3 of them, that are postulates. We don't have to prove that because they just are common sense. One's a theorem, 2 of them are theorems, and one's a particular theorem. Okay, so sometimes it's helpful to describe the parts of a triangle in terms of their relative position. So a lot of times we'll talk about what's opposite this and what's included here. So here's some vocabulary. So side AB is opposite angle C because it's the angle that sits across from it. Okay? All right, the second one, go away. AB is included, okay, so side AB, that segment, is included between angles A and B. So you take the side that connects those 2 vertices where those angles sit. A lot of times you'll hear people say that those are included. All right, we can also say that angle A is opposite side BC. So an angle can be opposite a side can be opposite an angle. And then the same thing here. Angle A, so this angle right here, is included between side AB and side AC. So sides can be included between angles, angles can be included between sides. Now, the included part, you don't hear quite as often as you do opposite. You hear opposite all the time. Like, this is opposite this. This is, of course, a lot of times people just say across from, but they mean opposite when they say that. Okay? All right, so the next postulate, again, we don't have to prove it, but if we have side, angle, side, so let's say we take one triangle, we'll call it ABC again, and another triangle that we'll call DEF. All right, and we know maybe angle A is 40 degrees big, and so is angle E. Then maybe side AB is a length of 8, and so is this side right here. But this side is 10 long, and so is this right here. Okay, so, hang on, I guess I should probably add, I feel like I just sort of ran through this. So side, side, side. We had one side congruent to a side. We had a second side congruent to another side. We had a third side congruent to another side. So that's why it's called side, side, side. If you show that in the two triangles, all three side lengths are congruent to the corresponding ones in the other one. You say those triangles are congruent with side, side, side. Now, notice this is side, angle, side. So it has to be in that order. Like you have to hit, okay, here's a side that's congruent. Here's the angle at the end of that side length. And then here's the other side that's congruent. So I hit the side, then here came the angle. So that angle is included between those two sides. That is another way of proving that two triangles are congruent with side angle side congruency postulate. And the reason it works is because if you, now it won't work on anything but a triangle. But if you take a triangle and you fix that angle right there, it's 40 degrees. And then you surround it with two sides that are the same length, the corresponding parts are, like you're setting yourself, like this has to be a length that's the same as this one. Like it can't, it's a hinge, you know, like you're doing the exact same thing with the exact same stuff. So for this one, we would say that, like we just pick how you want to name the first triangle ABC. Okay, so angle A is that 40-degree angle. So we have to name angle E first on the next one because they correspond. And then if I went B, I'm going down that green side. I'm going down the side that was 8 long. So I'm heading towards angle D. And then I'll end up with F. And you say by the side angle side congruency postulate. And again, you don't have to write postulate. It's just side angle side congruency. All right. The next one that's a postulate is angle side angle. So we'll start out. We'll call it triangle ABC again. We'll have another one that's triangle DEF. So we're looking for an angle, then a side, then another angle. And they have to be in that order. See, like up here, it went, I hit the side, then came the angle, then hit the other side. The side hit the angle, then the other side. Like the angle has to be between, has to be included between those two sides. So this one, we're going to have a side included between the same two angles. So let's just start marking this up. Let's say we know angle A is 60 degrees. And over here, let's say angle F is that same 60 degrees. And then angle B up here is 70 degrees. And let's say angle E up here is also 70 degrees. And we know that this length is 10, and this length is 10. Okay, so you notice we hit an angle. Then here came the side. And then here was the other angle. So it's in that order. Now the reason this one works is because if you know those two angles of a triangle, 60 and 70, then we're already up to what, 130? So this has to be 50 degrees and this has to be 50 degrees. So you've already created similar triangles. I know we haven't talked about that, but we talked about it a little bit in 8th grade math, where similar triangles are just the same shape. But it could be a blown up or shrunk down version. But if you put a corresponding side, like you know that sits across from this 50-degree angle, it sits across from this 50-degree angle. You've already shown that these two triangles are the same size, or sorry, the same shape. We just, if you put a side length that has to be the same length in the same spot on both of them, then there's no way around these two triangles being congruent. So we would say triangle ABC. So again, you just name the first one what you want to. All right, so angle A was the 60-degree angle. Angle F was the 60-degree angle over here. And then B was the 70-degree angle. That was E up at the top. And that leaves D. By angle, side angle, congruency postulate. Okay? All right. Now we're to the theorem. So we'll actually prove this one. This one's angle, angle, side. So if two angles and a non-included side are congruent to the corresponding parts of another triangle, then these two triangles are congruent. So let's draw a picture. So we're going to have triangle ABC and triangle DEF. So this is given. So this is, we need a diagram to look at. We know that angle B is congruent to angle E. That E looks weird. Let's fix that. We know that angle C is congruent to angle F. And we know that AC, this length right here, is congruent to this length right there. All right. And we're trying to prove that these two triangles are congruent. So we're going to have our statements and our reasons. So number one, I'm just going to list all the givens. That doesn't look like congruent. Let's make that look better. Angle C is congruent to angle F, and AC is congruent to DF. All right, so this is what was given. Now, technically, that first statement doesn't have to be written because we drew a diagram to go, like, because you have the picture that shows the two triangles, we could get away with leaving that out. But most people are just going to go ahead and put it anyway. All right, now, the next thing we know, so we have our two triangles. We know that two angles match up. That means the third ones have to. And I can't remember where this was. Was this in the section 4.1 notes? I think it may have been. I can't remember. But that means that angle A has to be congruent to angle D, because in a triangle, two angles being congruent implies that all three are, because they're adding up to 180. And because that's the case, then we can use one of our postulates. So now we've got right here angle 3, side 1, angle 2. Angle 3, side 1, angle 2. Now we're back to angle, side, angle. So we can say that triangle ABC is congruent to triangle DEF because of angle, side, angle, congruency postulate. Okay. Now, I guess I should have mentioned this a little bit more. We had our two triangles. Angle B was congruent to angle E, so there's two angles. Angle C is congruent to angle F. And then we've got side AC being congruent to side DF. So see how it goes, angle, angle, side, angle, angle, side. I will tell you, when I was in high school, we didn't use, the textbook that we used, we only used 4 congruency postulates and theorems because we combined those two into a single one. We called it the angle, angle, side congruency, and I think we called it a postulate because as soon as you have two angles that are congruent in two different triangles, the third angles have to be congruent. And so you just have to figure out, like, there's my 3 angles, and then let's put a side in the same place. Because the 3 angles are what make it similar, and then that extra side is what makes it congruent. But that's the only textbook. We use the Saxon math books. That's the only book I've ever seen do that. So you would get weird looks if you told, like, that's angle, 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 side, because most people don't know that's ever even been a thought. So probably shouldn't even brought it up. But if you see, like, angle, angle, side, we can say that we have 2 congruent triangles. All right, and then our last method is only good for a right triangle. And I know you know this. I feel silly even writing it down, but, you know, that's a leg, that's a leg, that's a hypotenuse. You're like, yeah, duh, Miss Brant, I know this. All right, so the hypotenuse leg theorem. It says if the hypotenuse and a leg of one right triangle are congruent to the corresponding parts of another right triangle, then these 2 triangles are congruent. So basically, let's just draw ourselves 2 triangles and say, like, this length is A, here's B, and here's C. And we got a second triangle over here that has the same hypotenuse length, and it has the same leg length, but it has, we say it's a different length over here for the second leg, the third side. But we know that A squared plus B squared equals C squared from the first triangle, which implies if we rearrange this, we'd get the A squared as C squared minus B squared, so we'd know that A is that principal square root of C squared minus B squared. Okay? If we did that same thing down here, we know that J squared plus B squared is C squared. So J squared is C squared minus B squared. I'm going to put it on here. So that's that principal square root of this. And so if A is the principal square root, why is it not right? Of C squared minus b squared, and j is also the principal square root of the quantity c squared minus b squared, then that means, what is that? Therefore, a has to equal j. Oops, I forgot to put the 2 tick marks there. And now we've got side, side, side. So, but you don't want to have to go through that every time. So what happens, is, let's say you've got triangle ABC. It's a right triangle. Hypotenuse and a leg are congruent. We draw some other right triangle. And maybe we call this, we'll put EF and D again on here. Let's say that this is the same length as side 2. So CB and FE are congruent. And then the hypotenuses are the same. So you have a hypotenuse and you have a leg. So we would say that triangle ABC, let's make that look a little bit more like a C. That looks kind of goofy. Is congruent to, okay, so A was the angle that's included between the blank side and the hypotenuse. So the blank side and the hypotenuse, that's where corner D is. What's next? B is the other acute angle, so that's got to be E. And then C was the right angle. And you'd say that's by the hypotenuse leg congruency theorem. All right, so today you're going to do 4 different worksheets, and they're not supposed to be hard. They're just supposed to get you to quickly being able to spot when it's which of these 5 theorems it is or postulates it is, and also when is it not. Like, a lot of people always end up saying, is there an ASS? No, there's not. And we'll talk more about that later, but, you know, like angle side, side, you could have like a 40-degree angle, and this side be 4, and this side be 6. And then you could have a 40-degree angle, and then, let's see, we're going to go, oh, this doesn't look right, but a 4 and a 6. Like, it doesn't have to, you could have an acute or an obtuse. So it is little, it's only these 5. This is the only 5 ways ever to prove that 2 triangles are congruent. So once you get this, you're good. But yeah, you're going to work all these worksheets. You're going to check them, and then hopefully tomorrow you're going to be good to go. Let's turn this